Now, this video discusses about what we call as the symmetry of the function. So, what is the symmetry of the function? But before we go further, you should have to understand about what we call as the line of this, or actual line of the symmetry. Let's say we have should be a rectangle, and a line of symmetry, it is the line that is to cut the rectangle into two equal parts. That is what we call as the line of symmetry. It is a line that is to cut the rectangle into two parts. And for instance, we can have this as the line of symmetry, and even we can have also this one as the line of symmetry, should be that. Or else you can also have this as the line of symmetry. A line that is to cut the rectangle into two equal parts. This is also a typical line of symmetry because it is cutting the rectangle into two equal parts. So different actually objects has got the different orientations of the line of symmetry based on the shape of the object. And let's say if we can have, let's say this is a typical circle. Now the symmetry line of the circle can go like this. This is the symmetry line, and even this one, this is also the symmetry line. So based on the shape of the object, we can have different actually lines of symmetry, and some objects do not have the lines of symmetry. In other words, the objects cannot be divided into actually two equal parts. And sometimes we can also have the functions that may also possess the symmetry as well. Let's say we have this is a Cartesian plane. Let's say this is a typical Cartesian plane we should have to think about. And say we have a graph of the quadratic. Let's say this is a typical graph of the quadratic. Now as you can see, let's say this is the graph of should be f of x. Let's say this is the graph of f of x. Let's say it's equal to x squared. As you can see it here, the graph has been divided into two equal parts, and by the actually a y-axis. So which means the graph is asymmetric along y-axis or with respect to y-axis. So that's how you should have to understand it. So different graphs have got the different symmetry, either along x-axis, y-axis, or the origin. And we can also have this case of the graph as well. Let's say we have this typical graph. Let's say this is also the Cartesian plane. We can have, let's say this is a kind of a graph. Let's say we have a graph that runs like that. Let me just have this. Let's say we have the graph that runs like that. And also let's say the graph runs like that. So as you can see, the graph is symmetric along origin. It's because the origin itself has divided the graph into two equal parts. We have this part as well as this part. So different graphs has the different actually symmetric either along x, y, as well as the should be the origin. So analytically, without the need of the graph, how can you be able to determine the symmetry of the function if that is the case? How can you be able to determine the symmetry of the graph of the function if that is the case without the need of the actually the graph? Let's say we have the function f of x, let's say is equal to y. Now the graph of an equation is asymmetric about y-axis if replacing x with negative x, yields an equivalent equation. So for that case, it means that actually a graph is symmetric along actually x-axis should be about y-axis, in the sense that if we have a function, let's say f of x, and if we substitute the function with should be a negative x, it should have to use the same function as it was before, then the graph will be symmetric about x-axis. So symmetric about x-axis, we replace x with a negative x, and if it happens that the function actually, if it happens that upon substituting negative x for x, and I use the same function, it means the graph of the function is asymmetric about y-axis. And the symmetric about, let's say, should be y-axis. It is obtained upon substituting. It is the symmetric about y-axis is obtained upon substituting actually. By the way, the symmetric about actually y-axis, it is obtained upon substituting x for negative x, and the symmetric about should be x-axis is obtained upon substituting upon substituting y with negative y. And if it happens that the function that we obtained yield the same function, it means the graph of the function is symmetric with respect to the x-axis. And if now the symmetric about the origin corresponds to substitute x with negative x and y with negative y, and if the function yield the same function as it was before, then the function is said to be the symmetric about the origin. And let's say we have the following cases, and let's appreciate. Let's say we have the function given as, let's say, f of x is equal, let's say, x squared and plus 4. Mind you, having f of x, it is the same as y is equal to x squared and plus 4. So let's use this function. So determine if the function is symmetric about, let's say, x. Now the symmetric about x, we replace y with negative y. So for this case, we'll have it as the negative y and is equal to x squared plus 4, and we'll have to divide everything by negative 1. We'll have y is equal, should be negative x squared plus it should be negative 4. Now as you can see, the function obtained, it is different from this one, hence the function is not symmetric about x-axis. So not symmetric about x-axis. Now how about the symmetric about the y-axis? Now the symmetric about the y-axis is obtained upon substituting x with negative. So have it as y is equal, we have negative x to the power 2 and plus 4, which is the same as that of x squared plus 4. And as you can see, what we have obtained, it is the same as the original function. Really, the function is symmetric about the y-axis. And how about if we have, let's say, this kind of a function? Let's say have the function f of x is equal to, let's say, x to the power 3 minus 7x. And mind you, having f of x, it is the same as y is equal to x to the power 3 minus 7x. So let's start with the symmetric along origin. On the case of the origin, it corresponds to have negative y and also negative x. So we need to substitute where there is x with negative and y with negative. So we have negative y is equal, we have negative x to the power 3 and plus that of should be 7x, and I'll have to divide everything by negative. That will have is, y is equal to x to the power 3 minus 7x. As you can see, we have obtained the function which is the same as the original function. Therefore, it is asymmetric along the origin. And how about, let's say, if we have this? Let's say if we have the function f of x is equal to, let's say, 1 over x squared, should be that. So let's see the symmetric about, let's say, the origin. Now the symmetric about the origin will have negative y is equal 1 over negative x to the power 2. And then in this case we'll have it as the negative y is equal 1 over x squared. And this is the same as y is equal to negative 1 over x squared. And this function is not the same as the function. Therefore, it is not symmetric about that of should be the origin. And also let's try the symmetric about, let's say, that of the y-axis. Now for that case we'll have y is equal to 1 over negative x to the power 2, which is the same as y over x squared. Therefore the function is symmetric about the y-axis. And how about, let's say, if we have a case like this? Let's say if we have the function f of x, which is equal to x over 1 plus, let's say, x squared. So what can you say about the symmetric, let's say, about the origin? So on the case of the origin, it means we have negative y is equal, mind you, f of x is the same as y. So negative y and negative x over 1 plus negative x to the power 2, which is the same as the negative y is equal to negative x over 1 plus x squared. If that is the case, you should have to understand that upon making y as the subject, we'll have x over 1 plus x squared. As you can see, the function we have obtained, it is the same as the original function. Therefore, the function, the graph of the function should be, the equation of the graph of the function is symmetric along the origin, or should be with respect to the origin. So keep that in mind. Let's say if we have something like, let's say we have the function f of x, say is equal to e to the power x plus, let's say, e to the power negative x. So now what can you say about the symmetric of the function? So let's start with, let's say, you can have to start whichever the test of our interest. Let's start with the origin. About the origin. Now on the about the origin, we'll have negative y is equal x to the power negative x and plus e to the power. Now we'll have it as a positive x. Since this negative and the other negative, it means we'll have it as the positive x. We'll have it as that. And dividing both sides by negative, we'll have it as y is equal to negative, should be that, and the minus e to the power positive x. Now the function that we have is not equal to the original function, therefore it is not symmetric about the origin. And how about the x-axis? What did you say about that one? So principle remains the same. We'll have the negative y, which is equal to e to the power negative to the power, should be positive x rather, to the power positive x plus e to the power negative x, of which y will be given as the negative e to the power x, the negative e to the power negative x. So as you can see, the function that we have obtained, it is not the same as the original function. Therefore, it is not the symmetric about the x-axis. And how about the y-axis? What did you say? About the y-axis, principle remains the same. We'll have it as the positive y and e to the power negative x and plus e to the power positive x, we'll have it as that. Now, as you can see, we have obtained the function which is the same as the original function, because you should have to understand that having a minus b, this is the same as having negative b plus a. So that's what you should have to understand about what's happening there. So therefore the function is symmetric about actually that of the y-axis. So keep that in mind. So because here we have e to the power positive x, well, actually the positive one also have e to the power x, the positive one, plus e to the power negative x, e to the power negative x. So it means the function is symmetric about actually a y-axis, as you can see there. And what if, let's say, we have a case like this? So what did you say? Let's say if we have the function f of x, and which is equal to sine x, and plus, let's say, cos x. So determine whether the function is the symmetric about the x-axis, y-axis, or the origin. So in this case, you just have to try this at your own time, and just have to see how best you can have it. But let's say if we have the function f of x, let's say is equal to the absolute value of x, and minus x to the power 3. How do you think we can have this? So let's start with the origin. So origin corresponds to have negative y is equal absolute value of negative x and the minus negative x to the power 3, of which you have negative y, and what is the absolute value of negative x? That is positive x, and negative, what is negative x to the power 3? That is negative x, so x to the power 3, and it times this negative, will have it as a positive x to the power should be 3, and we'll have y is equal to negative x to the power 3, and that corresponds to have it as y being given as. And by the way, let's consider this case. Let me take it back, and we should also have to see it on the another orientation, and for the better clarification. You should have to understand that according to the properties of the absolute values, if we have the absolute value of, let's say, any positive number is the same as the positive number, and also the absolute value of any negative number is the same as the positive number. So in all cases, you should have to understand that, let's say if we have to test the symmetry about, let's say, the origin, so it means we have negative y is equal to, we have the absolute value of negative x and the minus negative x to the power 3. Of course we have that one, and the minus y is equal to, and the absolute value of negative, let's say, should be x. This is the same as the absolute value of the positive x, and that will be given as, what is the absolute value? It should be what is negative x to the power 3, that is negative x to the power 3, and times this negative, we'll have it as a positive, so which means we'll have here positive, that is should be that of x to the power 3, like that, and dividing everything by negative 1, we'll have y negative absolute value of x and negative x to the power 3. As you can see, this function is not the same as this, therefore the function is not symmetric about the origin. And how about the symmetric about, let's say, the x-axis? What did you say? Now for this case about the x-axis, it means y will be given as actually negative, we'll have it as that of absolute value of x, and plus should be minus x cubed, like that, minus x cubed, and then dividing everything by should be, in actually negative 1, we'll have a negative absolute value of x, and that should be a positive x to the power 3 upon dividing everything by negative. And of course, in this case, as you can see, this update function is not the same as this one, hence the function is not symmetric about the x-axis. And how about the symmetric about the y-axis? Now for that case, we'll have the y equal to, we'll have it as the absolute value of negative x, and we should have it as, negative and negative x to the power 3 should be that, which is the same as absolute value of negative x. It is the same as absolute value of x. And for this case, what you can have is something about plus x to the power 3. And it's true, as you can see, this function is not the same as this function. Therefore, it is not symmetric even about the y-axis. So take note of that case. That's how we should have it there. And what if, let's say, we have something like and I'll try the following cases at your own time. Let's say if we can have the function f of x is equal to 1 over x, and let's say if we can have something about, let's say, f of x is equal to the absolute value of x minus, let's say, x squared. And let's say if we have something about, let's say, the function f of x, which is equal to the square root of 9 minus x squared. And also, let's say we have the function f of x, and which is equal to 5x to the power 5, and plus 3x squared should be cubed rather, plus that should be the x. So you should also have to try that one as well. And let's say if we have the function f of x should be sin x plus cos x, and also we should have the function, f of x is equal to, let's say, tan x. And let's say we have another function which is f of x is equal to, let's say, x squared sin x. And also, if you can have the concept of the function f of x, let's say is equal to cos 2x. And by the way, on the case of the trigonometric functions, here is how you should have it as the working principle. Now, you should have to understand that using the trigonometric identities, if we have, let's say, sine of negative, let's say, x, this corresponds to have it as, if we have the sine of negative x, this is the same as having it as, should be about negative sine x. And that is to say, if we have, let's say, sine negative 2x, and this is the same as negative sine 2x. That's what it means. If we have, let's say, sine, let's say, negative 5y, this is the same as negative sine 5y. That's what it means. And also in the same case, if we have, let's say, cos of any negative, let's say, number x, this is the same as the positive cos x. So in all cases, which means if we have, let's say, cos, let's say, negative 2x, this is the same as a positive cos 2x. So that's what it means. And also bear in mind that if we have tan x is the same as the sin x of cos x. If we have, let's say, tan 5x, this is the same as the sin 5x of cos 5x. Likewise, if we have, let's say, tan negative x, You know, this is the same as having it as a sine in negative x, and then divided by the cos negative x, you know, which is the same as having it as negative sine x of cos x, according to these actually trigonometric identities. So that's how you start to understand about the actually a symmetry of the functions. Thank you.